Welcome to Ghana New Schools. Today we are going to look at one of the important concepts under approximation. So significant figures we see refers to non-zero figures. To leave digits in specified significant form, start from a non-zero number and count to your right. The following rules are considered when writing digits of figures in significant form. All zeros that are found between non-zero digits are significant. For example, 3006 has a total of 4 significant figures. In this case, these particular zeros are all measured. All non-zero digits are significant. For example, the value 211.8 has 4 significant figures. Leading zeros to the left of the first non-zero digits are not significant. Thus, 0.0075, for example, has 2 significant figures because the these zeros, before the 7 are placeholders and are not significant. Trailing zeros for a whole number that ends with a decimal point is significant. For example, 430 with its point, the decimal point, has a total of 3 significant figures. If the decimal point was not written, thus we having only 430, you will say this has 2 significant figures, which is the 4 and 3. Trading zeros to the right of the decimal place are significant. This means a value such as 102.00 has a total of 5 significant figures. Finally, when we write a number in scientific notation, these m times 10 to the power n, only the part m is counted in significant figures. With this in mind, let's look at our first example. Example 1. You are to correct 87,563 to 3 significant figures. Solution. Realize that the first number is 8 and not 0. Hence, we start counting from the 8. Therefore, we have 87,563 to be equal to 87,600 to 3 significant figures. What happened? We added 1 to the 5, making it 6. That's 1 plus 5, giving us 6. This particular 6 equals the number after the 5, which is this, okay, after this 5, is more than 5. Yes, so this is more than 5. What if someone will say, what if it's less than 5? Let's look at the second example. We found out about that. But for now, what you should be sure of is anytime the number after the last significant figure you have to approximate to is more than 5, you have to run up. Example 2. Express 76,843 to 3 significant figures. Solution. So this is a solution. You realize we have 76,800 to 3 significant figures. And with this, 4 and 3, these digits are less than 5, so we run down. Now let's take our third example. Correct 76,845 to 3 significant figures. Our solution, we have 76,800 to 3 significant figures. And since our 4 is less than 5, the 4, this particular 4, just after the 8 is less than 5, we run down. So I will urge you to try this example whilst you pause the video. After the example, try to see if you had these answers. Now let's throw more light on example 2, which is at a point where you run up by adding 1 to the 9, you realize that you get to 10. So in this case, you have to run up again. Okay, and there we have 4. So it's just this addition. Adding 1 to the 9, realize you have to run up again, taking the number places into consideration. Now, the last one. Thank you. Let's look at the next example. Example 4. Correct 0.038871 to two significant figures. Solution. These will give us 0.039 to two significant figures. The only difference here is the decimal place. The first non-zero digit is 3. Hence, we start counting from 8 to the right. Don't forget these 0.0 that we have here, they're just placeholders, not significant figures. Now, somebody will ask, why do we leave the other figures at the back? Why do we say they are insignificant? In this case, why didn't we write 00s? Let's take a look at this fifth example, and you get to understand better. In case we should write them, then we are considering them as significant when it comes to decimals. Example 5. Express correct to three significant figures, 0.004596. Our solution, we have 0.00460. In this case, our first significant figure is 4, and the second one is 6. The third one here is 0. So in this case, the 0 here is measured. So what's happened? By our addition, when we run up this 6, which is more than 5, and in attempt to add a 1 to the 9, these add the 1 to the 9, realize we have 10. So we have to run up again, giving us 6. So by adding 1 to the 5. Now try this exercise, and I will advise you to pause the video and continue after the exercise. So let's see what we had. Considering our solution, let's look at question 3 and 4. Now we have 5 after the decimal point, but we have other decimals trailing behind it. For that reason, we have to run up by adding 1 to the 6. But we still bring the decimal point because there are other decimals trailing behind before we deem them to be insignificant, giving us our three significant figures. But in a case where we discard even a decimal point, or we try to leave the decimal point out, then we are referring to whole numbers. We are saying the numbers are not giving us with decimals, right? Yeah. And as this one, as we did earlier on, you realize that when you approximate, you're trying to approximate by running up one of the 9, by adding 1 to this 9, you get 10, it continues till we get to our 2. Now let's look at the final aspects of this lesson. Example 1, correct 3.346 times 10 exponent 3 to three significant figures. Our solution. Now, we realize that we've not changed anything relating to the exponent. The only thing that was affected was these figures. We had 4 significant figures, but now we have 3. Since the 6 is more than 5, we have to run up by adding 1 to the 5. Yes. Now I will encourage you to pause the video as you try this exercise and compare your answer with these answers. Now thank you for watching. But in case you've not subscribed, I will encourage you to hit the subscribe button to keep in touch with the subsequent videos that will be posted. Thank you.